Here's some practice problems to review what we've been doing. The first example that I have here wants us to take this equation and solve for y. To do that, you want to make sure you have only one y. And notice I have a y on this side of the equation and a y on the right side of the equation. So I'm going to move the y that's on the right to the one on the left. You could move the one that's on the left to the one on the right. It really does not matter. So I'm going to have 8x plus 3y equals 4z. Now I want to solve for y. That's what the problem is asking me to do. So I want to get y alone. I will subtract 8x from both sides. It does not matter the order in which you put these. I usually put them in alphabetical order, but it really does not matter. You can put 4z minus 8x. And now I want to get my y alone by undoing multiplication with division. So my y is officially alone, and I have negative 8x plus 4z over 3. I'm okay if you stop here and leave this answer the way it is, or you may take each of those and divide them by 3, but they will not simplify. What's strange about this problem is the fact that I have two n's, and unlike the problem up here, I can't combine these two n's to make one n. So from our notes, we were told that we need to undistribute the n. So I'm going to undistribute. Remember, distributing is when you have a factor outside of a pair of parentheses in which you're going to multiply each of these terms. N times what gives me 8np. 8p. N times 8p is 8np. And then n times what would give me negative 13n. Well, that would be negative 13. So I have undistributed the n, and I officially have one n, and that's what I'm trying to solve for. So I'm going to divide both sides by 8p minus 13. That undoes the multiplication that's occurring between this monomial and this binomial. That leaves my monomial of n alone, and n is m divided by 8p minus 13. You may also use the symmetric property of equality and rewrite this as n equals m divided by 8p minus 13. Both of those are correct. For my next problem, it's a word problem, I do want an equation. I don't just want answers. I want you to solve using an equation. I'm going to make a table. I want to highlight, so let me grab a highlighter, a couple of highlighters. I want to highlight and show you where some of these things go. And this same pattern occurs in almost every single problem that you'll encounter in these age word problems. So Garrett is 4 times older than Sally. That is our now information. Right now I know that Sally is X and Garrett is 4 times that age. Next, I'm going to use this information in 4 years for my then column. So in 4 years, 4x plus 4 would be 4 years from now, and x plus 4 would be 4 years from now. And then to finish, I'm going to use this sentence. This is what makes my equation. The other information is just what helps me get to making that equation. I want you to look for your verb. Will be is my verb. That's where your equal sign goes. To the left of your verb is what goes to the left of your equal sign. In 4 years, Garrett. So how old will Garrett be in 4 years? Garrett will be 4x plus 4 in 4 years. Garrett will be twice, which means to multiply by 2, twice as old as Sally. How old will Sally be in 4 years? X plus 4. And now, I tell my students very often that once they get to this point, they do not need me. They know how to solve a simple equation. They can distribute. And move their constant to the right and get their variable alone. So this tells me that Sally is 2 years old and Garrett, I left an R out, Garrett is 4 times 2, which is 8 years old. That's my answer to my word problem. The mean score on the math portion of the SAT is 480, and I just made this up. I don't know what the mean score is. I could have Googled it, but I didn't. And the score can vary up to 20 points. I'm going to draw that on a number line. The mean is the average, so that's going to go in the middle. And it can vary up to 20 points. It could be 20 points higher, which is 500. It could be 20 points lower, which is 460. Okay. Now I want to write an absolute value equation. Your variable always goes here. In this spot, you put a number, and in this spot, you put a number. What are those numbers? The opposite of the mean goes here. What is my mean? 480. So minus 480 goes there. And we're talking about absolute value. What does absolute value equal? Or what is the definition of absolute value? It's the distance. So this number here is the distance the data values are from the mean. 500 and 460, how far are they from the mean? They are 20 units, either 20 units forward or 20 units backwards. So 20 is what goes here. And that is my answer to writing an absolute value equation that would fit this scenario. I hope that those problems help you review the material we've been learning. If you have any other questions, please feel free to reach out to me. I'd be happy to help in any way that I can. Have a wonderful day.